Hello friends, so today we are going to learn about how to use a meter bridge for finding the unknown resistance and resistivity. So the aim of our experiment is to determine resistance of a given conducting wire using meter bridge and determine the resistivity of material of wire. Okay, and apparatus will be a meter bridge, a battery, a rheostat, a galvanometer, a jockey, a resistance box, unknown resistance that will name it as Rx, a simple key, a micrometer screw for measuring the diameter of the wire, and connecting wires. So let us first, yes, you can see the circuit over here. Okay, so accordingly we will connect the circuit. Here we have two L-shaped strips, okay, and we find two gaps over here. So in this gap we will connect the unknown resistance, in this gap we will connect the known resistance, that is the resistance box R3, and at point B we connect a galvanometer, and galvanometer is connected to the jockey, and between these 2 points A and C we connect the battery, rheostat and a key. Okay, so let us first do so this is the meter bridge. Okay, and you can see that there are two L-shaped strips here. One is here and the other is at the other end here, and there is one straight strip over here. So two gaps are formed. Okay, one gap is here, another gap is here, and here we have a this resistive wire which can be made up of nichrome, manganese or constantan, which is 1 meter long. Okay, that runs from this end to the other end, and the left end we name it as capital A. Okay, so you can see that there are two gaps, one is here, another gap is here. So now we'll connect the unknown resistance whose resistance and resistivity we want to measure, so that we are connecting in this left gap. So first part of the experiment is to have the unknown resistance in the left gap, and we have here a resistance box. Okay, and you know how to use it. For example, as you can see that the key which is numbered as 1, if that is taken out, so we have, this will work as 1 ohm resistance, and if you take out, for example, 5 and 1, that means the total resistance will be 6 ohm. Okay, so this is how we use it, and we will connect this resistance box in this gap, the right gap. We are connecting this cell or a battery, a key and a rheostat. Okay, they are connected in series. So you can see that I am connecting the cell's positive terminal, it can be other way also, to this left end of this resistive wire. Okay, then from the cell we have the key, and from the key we go to the rheostat, and you know how to use the rheostat. Okay, this lower fixed end we use, and the above slider, okay, that is the slider end we use, and this wire will be connected to the right end of the meter bridge wire, or we name it as end D also. You can connect it here also or here also, there is no problem. Okay, now one thing that is remaining is the galvanometer and jockey. So we connect the galvanometer over here at the middle, this terminal, and from galvanometer we connect it to the jockey. So you can see that connect galvanometers one end here, and galvanometer other end terminal is connected to the jockey, which will be slided on this resistive wire. Okay, now we will first of all check the connection of the circuit. So I am starting this circuit by putting this key over here. Okay, initially you keep the slider at middle position. Okay, now what you have to do, you have to just you take out some resistance. For example, 2 ohm or 3 ohm we take out from the resistance box. As you can see that 3 ohm I have taken out. You can take out 2 ohm also, and then you connect it to the left end and see what is the deflection of the we have taken out. Okay, 2 ohm pin from this. So in R3 we are keeping 2 ohm, and now we'll put the jockey on the left end of the wire. So you see that deflection of the galvanometer is towards left, and then we will touch it to the right end. So it is going to the right. It means the connection is all right, so we can proceed with our experiment. Okay, now let us see the observation table, and before that some observations are there. Okay, so see in observations we have the length of the wire of the unknown resistance, that is capital L. So for that, as we have done in the Ohm's law, okay, we use this thread, and we will start from here, and we will go along the length of the wire. Okay, then hold it here and then put it on the 1 meter scale, so we can come to know that what is the length of the wire. So here it is 57.5 centimeter. So that I write it in the observation, 57.5 centimeter. Next we have to measure the diameter of this resistive wire. Okay, meanwhile you switch off the circuit. Okay, we have to measure the diameter of this resistive wire, and for that we are going to use this micrometer screw or screw gauge that we say. You know that how to use it. Okay, you know that this is the main scale of it, okay, in which the least count is 1 millimeter, that is 0.1 centimeter. That is distance between two consecutive markings or two consecutive divisions of the main scale. And this is the circular scale, in which you can see that we start from 0, then we have 10, 20, 30 like that. Okay, last is 90 and back to 0. That means there are total 100 divisions on the circular scale. So you have learnt in 11th that what is the least count of this. So that is the pitch upon total number of divisions on the circular scale. So pitch is 0.1 centimeter and total number of divisions are 100. So 0.1 upon 100, that will give you 0.001 centimeter. That is the least count of this. So that we have written over here, 0.001 centimeter. Next we have to see that whether this instrument has any error or not. So for that, okay, you know that we will close it like this, and in this position you see that the zero of the circular scale is lying above the main scale. Okay, so this is the main scale, and the zero is about 11 divisions, over the main scale. So you know that what will be so this type of error is called negative error, and that error will be minus 11 into LC. That will be minus 11 into 0.001 centimeter. So that will become minus 0.011 centimeter. Okay, so that is the error in this instrument, and so the correction will be positive. So this will be plus 0.11 centimeter. This is the correction. Okay, next we have to measure the diameter of this resistive wire, okay, that we are, whose resistance we are measuring. So you can see an extra length of this wire is given, okay, in this. So we fix that wire in the micrometer screw, okay, and then we take the reading. So first of all we have the main scale reading. So as you can see that we are not able to see any line of the main scale after 0 because it is hidden behind this circular scale. So our main scale reading will be 0. So that we write here, okay, so that we write here 0 centimeter, that is our capital A, and then we see that which division of circular scale is coinciding with the main scale line. Okay, so it looks like 21, I can find it here. Okay, you can see that the 21 coincides with the, because see here we have 20 and above we have 30, that means the line above 20 is 21. So that, write it over here. So we write 21 here, and then so the diameter will become equal to A plus N into LC, that is 0. Okay, that just I do the calculation here. So 0 plus the N into LC, matlab ki 21 multiplied by 0.001. okay, so it will become 0.021. so our reading becomes 0.021. okay, same manner we will repeat this procedure 2 times more to get the mean diameter. So as you can see that we have taken 3 readings over here, and it mean will turn out to be 0.021. okay, and then we have to do the correction to it, so that then we'll get the corrected diameter, because the screw gauge has error that we have found above. So this much correction plus 0.011 has to be added in this, so the corrected diameter will become equal to 0.032, and so the radius of the wire will be diameter upon 2, so that will become 0.016 centimeter. Part where we are finding the resistance of this resistance box. So see, and we have to remember that we have to keep very low voltage, only we have to keep 2 volt over here. The key is closed and rheostat. Okay, now I have taken out 5 ohm resistance from the resistance box, so that I mentioned here in the observation table. Okay, so here say this part that we will do later. Okay, at present we are doing this part only where we have kept our unknown resistance in the left gap. Okay, so when we will complete this, then we will move to this part. Okay, so at present you have to just understand this. So R3, so R3 means what? R3 is this our resistance box. So you see that I have kept 5 ohm over here, so that I note it over here that I have kept 5 ohm. Now in this case I have to find out the balance length, means when I will get the null deflection in the galvanometer. So distance of the null deflection point from the end A. End A means the left end of the meter bridge wire, this end. Okay, so now I move the jockey on this wire, and I will try to see that when I get 0 deflection in the galvanometer. So here you see that we get 0 over here, and the reading is 56.5, as you can see, 56.5. okay, so that we note it here. So quickly 56.5, right, and the remaining, that is DC, will be 100 minus L. Okay, so now what is D actually? So see, this is A, and where we put the jockey, that point is D, and this end is named as C. So AD and then DC. Okay, now remaining, that is DC, will be 100 minus L. So this would turn out to be 43.5. So accordingly we do this. Now I repeat this step, the same step for 6 ohm in the R3, that is the resistance box. So now I get null point over here, that is at 52. Okay, 52.3 on the resistive wire. So that I note it here, 6, that is 52.3. So like that I have taken reading for total 5 such values of R3, 5, 6, 7, 8, 9, and I got the readings like this, 52.3. so remaining length will be 47.7. okay, so like that we have taken the reading for 7 ohm, 8 ohm and 9 ohm. okay, and now we have to do this calculation, that is Rx1, that is we are just getting in values of the unknown resistance. So that is R3 multiplied by L upon 100 minus L. So this is our L and this is 100 minus L. So as per formula, okay, it would be 5, rather say Rx will be 5 multiplied by 56.5 divided by 43.5. so this we have to do in the calculator, and that would be 5 into 56.5 divided by 43.5. so that turns out to be 6.49. so that I write it over here. So same manner we will repeat, we will do the calculation of all this 4 row. So we have done these calculations. Okay, now we have to do the other part where we have to connect the Rx in the right gap. Only we have to interchange the positions of the unknown resistance and the resistance box, and we have to repeat this procedure. Okay, what we have done over here. So I am interchanging their positions. As you can see, I have interchanged the position of the resistance and the resistance box. Now our unknown resistance is in the right gap and resistance box is here. So as we took the different values of R3 in same order, we have to take it again. So I have taken out 5 ohm resistance from R3, and now I am finding the null point. I start this circuit. So I get the null point over here. As you can see that it is at so we find it at 38 we are obtaining. So that we write it in our observation table. So Rx in right gap, balance length, okay, A D dash, so new L dash centimeter. So this we got 38.0. so remaining will be 62.0. so the same thing we will now repeat for 6 ohm, 7 ohm, then 8 ohm. So okay, whatever the readings that we now take, we will write it here. difference it from 100 and we'll do the calculation. So I show you the first calculation over here, and then we have to do all the calculations here. So I have taken 5 ohm, that is our R3, and the formula now is Rx2 is equals to R3 into 100 minus L dash upon L dash. So R3 was 5, so we multiply like this, 5 multiply by 100 minus L dash, which is 62, and divided by 38. Okay, so the answer is 8.15. Actually it is quite different from the previous one. So previous answer was 6.49 and this is 8.51. So actually it should be near, but no problem. I want to just show you the procedure over here. Whatever we have got, that is okay now. And now the last column, that is Rx is equals to Rx1 plus Rx2 upon 2. So see, these readings were our Rx1, and what we will get over here will be Rx2. So you have to take the average of these two and write here, the next two and write here. So what is the answer as per the first one? That will be 6.49 plus 8.15 and divide them by 2. So the answer is 7.32 ohm. Okay, now we will repeat this procedure for 6 ohm. So I take out 6 ohm from here. So now I have taken out 6 ohm from here, and I will find the null point. So I get it somewhere here, which is at 43.8. so that we write here. You can see for 6, R3 equal to 6, and we got here 43.8. so remaining will be 56.2. so the calculation will be R3, that is 6, multiplied by this 100 minus L dash, that is 56.2, and divided by 43.8. so the answer is 7.70. Okay, so we have got 2 Rx, this one and this one. So sum them. So 6.58 plus 7.70 and divide them by 2. So the answer is 7.14. Okay, so like that we will complete our table, and then we will see how to do the resistivity calculation. I have taken the reading for different values of R3, and okay, we got these length. Okay, and accordingly we have done the calculation. Okay, so we got the Rx2 as this, and we had the Rx1 as this. So we have taken the average and we have written over here. So different values of Rx that we are getting, 7.32, 7.14, like that. So we take out average of these. So that average I have written over here, 7.20 ohm. Now we have the calculation of the resistivity of the material of the wire. So as per the equation, R equal to rho L upon A. You know this equation, R equal to rho L upon A. So what will be rho equal to? It is RA upon L. Okay, and the area will be equal to pi r square. So our equation becomes rho equal to Rx into pi r square upon length. So Rx is 7.20 ohm, pi is 3.14, and R, that is 0.016 centimeter. Okay, we are writing this in centimeter only, and we are writing the length of the wire also in centimeter, that is 57.5 centimeter. So the answer will be 0.000106 ohm centimeter. Okay, in ohm centimeter you will get this answer, and then we convert it into meter. So only you have to replace centimeter by meter. So 10 raised to minus 2, okay, meter it will become, and this number as it is, and then the final answer, okay, after converting this into power of 10 raised to minus, so that will be 1.006 10 raised to minus 4 for this, and we have 10 raised to minus 2 over here. So the final answer will be 1.006 into 10 raised to minus 6 ohm meter, and that we write it in the result that unknown resistance Rx equal to 7.20 ohm and resistivity of the material of the wire is 1.006 into 10 raised to minus 6 ohm meter. Okay, so our practical gets completed over here.